Perfect. Fantastic. So welcome everyone. This is a presentation about the Cloud Initiative reference architecture and why it is an industry first. So Stefan already introduced the Cloud Initiative. This is something that we started over a year ago. We really wanted to accelerate the adoption of OPC OA in the cloud and really bring the entire ecosystem of cloud vendors and also automation vendors along with us. And this is why we set up the Cloud Initiative. Specifically, we had use cases like support for EU Data Act, CRA, digital so Cloud Resilience Act, Cyber Resilience Act, sorry, and then also the Digital Product Passport or DPP in mind, but also in general making cloud applications more interoperable with one another. So we got together as a group of cloud vendors and then later on also industrial automation companies and started developing a reference architecture. And very soon we also set up an end user council to validate what we had come up with is actually what customers want. And we got some of the largest names in manufacturing in the end user council. And as an OPC Foundation member, you can join the end user council free of charge. So really it's an industry first because I can't think of any other initiative that has combined the intellectual horsepower of all of these companies under a single roof. Really, it's not just participation, but also actively engaging and actually providing information to the Cloud Initiative. And as you can see, the reference architecture is not just an idea. We even have a mapping of products from cloud vendors directly into the reference architecture and how they interact with one another. We also extended the products mapping to the products from automation companies. Because nowadays an automation company not only provides automation equipment, but also cloud services to go along with those pieces of equipment. And it was only natural that we also wanted to have them mapped to the reference architecture. So finally, you can see here some of the end users that we have in the end user council. Please feel free to reach out to the OPC Foundation if you want to participate in the end user council. Is mainly to validate what we're building and also a way for you to ask for feature requests, of course. So with that, let's go deep into the technical details of the cloud reference architecture. Here it is. And to make it easy to talk about what it really means, we gave each component a number. And we also drew the interaction of the different components with one another in the diagram. So to give you detail, the gray box and all the components inside the gray box on the left-hand side are the components that run on premises at a manufacturing site. The bit in the middle, the big area in the middle between the two red lines, are services that are running in the enterprise cloud deployment of the manufacturer. And then finally, on the right-hand side, to the right of the red line, are two components that are important for data sharing along the supply chain, and they belong to the customer of the product that the manufacturer produces. So there's a lot going on. Also, regarding the arrows, right? So some of the arrows are OPC Way publish subscribe, specifically the orange arrows. So they are from the publisher to the broker or to the subscriber in this case, right? So it's important to realize that it's the direction of how data flows. But as you know, in IT systems, we not only have publish-subscribe architectures, but also client-server architecture, specifically implemented with HTTP REST, where you would access a web server interface And these are the green arrows, and they're in the direction of the request. So for example, the dashboard number 15 here makes the request to the production line time series database. The data itself then flows back to the requester, of course, but the request is initiated from the dashboard. This is important specifically when you're configuring firewalls and you want to know which ports need to be opened. The good news is from the on-premises systems outbound, only one port needs to be opened, 443, and inbound, no port needs to be opened. And that's specifically a request from the end users that we heard loud and clear. And then finally, we also have the OPC REST interface, and this is in gray. So the arrow here from the manufacturer's enterprise resource planning database outbound to its suppliers is handled with OPC REST, which is OpenAPI compatible. Very similarly, the customer ERP database makes a similar request via OPC REST to the asset admin shell library here in the picture. So these are like a little bit about what the arrows mean. And then maybe finally the black arrow, which is kind of the digital feedback loop, right? So from a cloud edge management application, a messaging application, you can send a message back to the cloud broker, and then the on-premises PubSub action processor would pick up that message and act on it. So for example, you could have the use case where you're creating a digital feedback loop regarding a process optimization. Maybe AI enabled, so you have an AI system that analyzes the time series data. You would pre-configure the inference engine to do and look for something specifically in the data stream, and then send a message to the cloud broker, which is picked up by the PubSub action processor and then executes that action on the shop floor on premises. The purple arrows are traditional OPC client server, right? So of course, on premises, you mainly have OPC client server still around. It's getting better and better with more and more companies supporting PubSub. I think there's over 50 companies now that support PubSub, OPC PubSub, mainly over MQTT, but we're about to make changes to the spec to call out other protocols. AMQP is already mentioned, UDP, of course, but we're also going to add Kafka to that protocol selection. But again, in general, PubSub can run on any PubSub-enabled protocol. So let's talk about the individual components. So on the left, number one, are the machines that are building a product. They are usually organized in production lines, and you have some sort of manufacturing execution system, preferably controlling the production lines through OPC client server. And you have this here under number 5. Then you have an edge broker, which is number 3, because modern machines already support PubSub, right? They have OPC client server and PubSub implemented, so the machines can send data to an on-premises edge broker or directly to a cloud broker using OPC PubSub, let's say over MQTT. So think of the oil and gas use case where you have an oil pump somewhere out in the desert, and it's connected to the cloud via wireless or satellite technology even, right? So this is a case where the machine would send data directly to a cloud broker. In general, you also have the need to map between OPC client server and OPC PubSub, and this is done through the PubSub data publisher component, which is sitting in box number 6. We already talked about the PubSub action processor. This can be the same component or in 2 different components, doesn't really matter, but they have the task to translate back and forth between OPC client server and PubSub, because there's a lot of legacy machines still out there that don't support PubSubs yet, and there always will be. So for that case, you need the PubSub data publisher and PubSub action processor. Then finally, on premises, we have, of course, industrial connectivity software that will translate between OPC client server and a proprietary protocol. Think of a Modbus machine or a machine with a Modbus interface. Obviously, you'd want to translate that to OPC UA. In this case, you need industrial connectivity software, which will then provide an OPC UA server interface northbound or to the outside world. And the PubSub data publisher and the PubSub action processor can then connect to the machine through the industrial connectivity software. Then finally, we have a application called the Information Model Viewer. It does exactly what it says on the box. It is a means to view OPC UA information models. For example, those stored in the information model library, which is number 13. So let's talk about the enterprise cloud a little bit. So I already talked about the cloud broker. This is kind of the front door service between a time series database and on-premises systems, usually through some sort of edge gateway. Then you also have usually an edge management suite running in the cloud, managing all the edge gateways. And finally, we already talked about the ERP database. It usually connects to a cloud service that handles the MES higher level functions. So usually the MES is split between the cloud and on premises. So the MES part that runs in the cloud would be connected to the ERP database. And again, you can have HTTP REST queries between the ERP database and the cloud MES service, between the cloud MES service and the production line time series database. Because, for example, when you're doing a production line query, it might be useful to have the shift times already present in the time series database, so you don't need to hit the MES service every time you run a query on the time series database. The information model library, I'll talk about this a little later as well, but it's basically an online store of OPC UA information models. The OPC Foundation hosts it under the name of UA Cloud Library publicly. And more recently, we have managed to translate the submodel templates from the IDTA, which are like information models, just in asset admin shell format. We managed to translate them to OPC UA to be able to store them in the information model library. And then we did the same for the over 200 models from Catena X as well. So the information model library has now become the place to get semantic information models in OPC UA format. And there are over 400 models now available in that library, which is also an industry first. So we have all the companion specs from the OPC Foundation, all the submodel templates from the IDTA, and all the BAM models from Catena X in one place, and they can all be edited and used using standard OPC UA modeling tools. Then finally, the other components also important in the cloud, enterprise cloud specifically, are a product database. Specifically for the use case digital product passport, you need to read product information from a database someplace, and that's covered in the product database. I already mentioned the dashboards, which usually are associated with a time series database. So you can build online dashboards where you combine the data from all your sites across the world under one dashboard, and you can start comparing data and so on. AI-assisted analytics are obviously a big part of cloud analytics these days. So there are separate applications for that, which then run on the time series data that you send to the cloud. And then we also have connected products sometimes. So the product itself, once it's purchased by a customer, would send data to a connected product database about its use. So this is especially relevant for use cases like the battery passport, where roughly a quarter of the data that is in a battery passport is actually usage data that needs to be collected during the lifetime of the product. And then let's talk about data sharing. So manufacturing supply chains inherently are meant for digital data sharing. And for use cases like product carbon footprint reporting, you really need to have visibility into your entire supply chain to calculate reasonably accurate product carbon footprint. And for that, you need a data sharing framework, and the Cloud Initiative has decided to use the data sharing framework from the International Data Space Association. This is specifically using two components. So they are working with the Eclipse Foundation, and the Eclipse Foundation is hosting a few components that are useful for data sharing. Specifically, one is called the EDC, or Eclipse Data Space Connector, and each manufacturer would have to host his or her own connector to establish data sharing along manufacturing supply chains. The data itself is then stored in a so-called asset administration shell library. More on that a little later. We've worked with the Digital Twin Consortium to build an asset admin shell library which hosts OPC information models, which is incredibly important, especially now that we have all the information models in the information model library from all three consortia that are building these information models. So you can host them in the asset admin shell library and then make them available, for example, to build digital product passports, and then share them using a data space, an industrial data space. This is kind of the overview. I'm sure there are additional details that are required for clarity. So looking forward to these questions. Please do not hesitate to ask. So as a next step, after we had pretty much decided that this would be it, maybe one more point. So obviously there are other systems that manufacturers use, but since they're not immediately relevant for the cloud architecture, we left them out. For example, there's no SCADA systems in here, but of course we know SCADA systems are used, right? So this is not supposed to be an overview of every single system that a manufacturer uses, but focus on the use cases that we have identified, which manufacturers ask the OPC Foundation about, and specifically how they interact with one another. So then we went off and created a mapping of this reference architecture to open source components. So any cloud provider can take this reference architecture and offer it to their customers using nothing but open source. The main applications here are well-known open source initiatives. Some of them are from the OPC Foundation itself. OPC Foundation obviously has a very thriving open source community. So the ones where you see UA Cloud something or UA Edge something, they are in fact from the OPC Foundation, and they can be found on the OPC Foundation GitHub. So again, you can take this and build it yourself today and start using it to offer services to manufacturing customers. One of the things that caused a lot of confusion in the market in recent years was, in fact, how to build these digital product passports. We got together with the IDTA, the Industrial Digital Twin Association, and of course the DTC, the Digital Twin Consortium, and built an architecture which basically takes the best of all three worlds, let's say, and we agreed to promote this particular division of labor, let's say. So for the interface, we all agreed we want to provide an open API compatible interface. So the Asset Admin Shuttle has one, OPC UA has one, and of course the Eclipse Dataspace connector has one with the Dataspace protocol being used there. So we decided that we will offer all three. For the data format, I mentioned it before, we've managed to translate all the semantic models to OPC UA, and it makes sense to store those semantic models in an OPC UA nodeset file format, which all the OPC UA modeling tools can use. For data modeling, like I mentioned before, we use the OPC UA modeling language. And then finally, for the semantics, we have specifically the Asset Admin Shell submodel templates. We have the Catena-X templates. And of course, we have the companion specs from the OPC Foundation. So all three are used. In fact, there is also work, and we'll hear about this later today. There's work to standardize the exchange or mapping of Asset Admin Shell data to OPC UA data. And this is handled in the so-called I4AES working group. And we'll hear a little bit about this later on. So very briefly, because there's also a presentation from the IDSA later on today, just briefly, the Eclipse Foundation hosts, like I mentioned, the Eclipse Dataspace components, and specifically the connector component is used to establish trust between a customer of a manufactured good and the manufacturer itself, right? So once that trust relationship is established, there's a digital contracting involved. Data can then flow from the manufacturer to the customer in relation to things like digital product passport, et cetera, et cetera. How does the tool chain look like when a manufacturer builds a digital product passport? Well, we tried this out together with SESME in the United States. SESME is like the Industry 4.0 in Europe. So we built a prototype specifically for a manufacturer of paper. So let's say the manufacturer has produced a roll of paper. That paper then creates or has an information model associated with it, which can be seen as the digital twin of the paper, of the product paper. And of course, using standard OPC UA modeling tools, you can create an OPC UA information model for this roll of paper. SESME calls them smart manufacturing profiles, but effectively they're information models, OPC UA information models. And then you can embed this OPC UA information model or smart manufacturing profile in an Asset Admin Shell and store it in the Asset Admin Shell repository I just talked about from the Digital Twin Consortium that has the ability to load OPC UA nodeset files. Or of course, you can store them in the cloud library, which again is used for semantic models, but you can also store DPPs in them. There's nothing that stops you from hosting your own cloud library and using it to store your digital product passports in it. Regarding modeling, so SESME actually took this very seriously and built an open source and free of charge online OPC UA modeling editor. They call that Smart Manufacturing Profile Designer. And recently they have contributed this work to the OPC Foundation, and the OPC Foundation will maintain and extend the tool going forward. We're also going to host an instance of the tool online, of course, where you can do your modeling without having to install anything. And it's already integrated with the cloud library, which makes modeling even easier because you can download all the semantic models and templates from the OPC Foundation, the IDTA, and Catena-X automatically. And then final point regarding the architecture of the Asset Admin Shell repository from the Digital Twin Consortium. It's also available open source. It basically has an OPC UA server built in. Therefore, it can load nodeset files. And then there's an OPC UA client, which directly talks to the server and provides the OPC UA REST interface, the Asset Admin Shell REST interface. And there's also a visualization for the Asset Admin Shells or OPC UA information models specifically in the UI. And then finally, there's a REST or Swagger API available in the open API format, so you can interface with it directly through your web browser. It has 3 additional components that we built over the years. Specifically, there's a data processing service for product carbon footprint. Built in the Sesame Smart Manufacturing Innovation Platform can be attached to the repository, and data from the SMIP, or SMIP for short, can be also used to model digital product passports. This was again part of the proof of concept that I just talked about. And then finally, there's a connector to the Azure Data Explorer service. Other connectors can easily be added, and again, we encourage, or specifically the Digital Twin Consortium encourages participation in this open source project. And then last but not least, here is a view of the reference architecture mapped to the Microsoft Azure cloud services. So now I'm wearing my Microsoft hat for a change or for a quick excursion. And of course, all of the services are available that you need, and the blue boxes are the services not directly offered by Microsoft, but instead we use the cloud library from the OPC Foundation, and like I mentioned before, Digital Twin Consortium Asset Admin Shell repository from the Digital Twin Consortium. And finally, there's also a reference implementation for industrial connectivity software that Microsoft contributed to the OPC Foundation called UA Edge Translator, and it supports the bot connectivity interface, which basically means it can load Web of Things thing descriptions to onboard assets fully automatically. And the Eclipse Dataspace connector is also part of this, and again, we use right now a implementation that is available open source from Fraunhofer. We are continuously improving the open source Eclipse Foundation products and services, so we will continue to invest there. And again, the whole thing is documented and available as a one-click solution on Microsoft Learn. So if you go to learn.microsoft.com, you'll find it there. Here's the link up there. So have a look at it, try it out. It comes with a production line simulation, so you see some data, simulated data flowing into the system, so it's not all just zeros, and it kind of shows the capabilities of the platform. Finally, please consider downloading the OPC Foundation Cloud Initiative brochure. It has a more in-depth explanation of all the different components, and also the mapping to the other cloud vendors and also the automation vendors that are part of the cloud initiative in it. And it shows the scope and broad application that we have for it already. What's next for the cloud initiative? Well, now that we have the reference architecture established and everybody agreed to use it, we're going to specifically work on a logo for compatibility. So we call that OPC UA CX, similar to what the field initiative did with OPC UA FX. So eventually you'll be able to buy OPC UA CX compatible products, which have been tested for compatibility with the cloud reference architecture, including the protocols and interfaces and data formats that it uses. So we really want to make sure that people can confidently buy these products and know that they will be compatible. So with that, I'm at the end of my talk. Thank you very much. Looking forward to the questions.